Okay, welcome to Pons University. Today we are going to be learning how to solve a system of equations using elimination. So far we have done a system where we had the coefficients were the same. Using elimination, now we're able to add them. Now we're going to have to multiply one of the equations in order to get there. So again, sorry about the little bright lights. They're kind of there, but it's okay. The glares. Okay. So a few things that we need to notice. As I said before, in the elimination that we're used to, we're able to combine these two when the lead number, or the lead coefficient, was the same. If we look at this, we have an 8, negative 16, and 7. So we don't really have a pair of coefficients that are opposites of each other. So we need to pick one to eliminate. Well, if I look here, 8 and 16, 16 is a multiple of 8. 8 and 7, not so much. So I'm going to eliminate x. Okay? Now, in order to do this, remember I need to get this coefficient to be the same, this one to be the same, have different signs, then we can add. Okay? Well, 8 is not the same as 16, but I know if I were to multiply it by 2, then I can just kind of see here, 2 times 8 gives me 16. So multiplying that guy by 2, 16x. And then when I think ahead, I'm going to be adding it to that negative 16x, and I'm going to eliminate my x variable. So I have to multiply everything by 2 to keep everything equal. So 2, multiply that by 2. Okay. And then if I look at my next equation, I didn't do anything to that. So I'm going to keep that one the same. Okay. Now we have our system that we're used to using elimination. If you look, if I add equation 1 and equation 2 together, so add 1 and 2, 16x, negative 16x, x gives us 0x, plus 16 plus 7, so 23. Then 32 plus 14 is 23y, don't forget that. Okay, 0x is just 0, so 23y equals 46. Divided by 23, oops. So y equals 2. Okay. Now I can use that information, and I can take this and substitute it anywhere I see y to get x. You can use this one, either of these, doesn't matter. It's the nice thing about a system of equations. I'm just going to pick the first one. You know, doesn't really matter. So now I have 8x plus 8, and instead of y, I'm going to take 2. That equals 16. So again, I just took y equals 2, substituted it in for 2 here. So 8x plus 8 instead of y2 equals 16. Now I can solve for x. So 8x plus 16. 0 minus 16. So I know that x is going to be equal to 0. So I know what my x and my y are. To write them as an ordered pair. Okay. So again, the key concept here to think of is that we try to find a number that we can multiply an equation by to get those coefficients to be the same. Because then once they were the same, we were able to add them, and that variable just dropped out. We eliminated it. Okay. Okay, so let's take a second and work on a problem. It's a little bit more difficult. Okay, so this problem now is going to be 7x okay. Now, if you weren't using elimination, there are a few ways that we could actually solve this guy. Could use a few nice little tricks, not really tricks, but cool things you do. But anyway, okay, so using elimination though, our goal is to be able to combine these two and to eliminate a variable. Well, if you notice, 7 and 4, okay, 6 and 4, it's not like last time. There are no multiples of 4 that give me a nice and easy 7. Same thing there. So I'm going to have to multiply both equations this time. Well, you could pick x or y. It doesn't really matter. We'll do y in this case. So we're going to eliminate y. Okay. And I'm also going to label these equation 1 and equation 2. Okay. So I'm trying to eliminate y. So I need these two to be the same. So I have a 6y and a 4y. I need those to be the same, just opposites of each other. So when I add them, they cancel out. Well, if you're not sure what a good multiple is to use between these two, one thing you could always do is just multiply the numbers, and you'll get a common multiple there. So it's not always the smallest, but it works. So I'm going to multiply this one by 4. And then remember, I want this one to be the same, so I'm going to multiply by 6. But I want the sign to be different, so I'm going to multiply by negative 6. Okay. So doing this gives me the same coefficient for y's, that when I add them together, the y is going to be eliminated. Okay? Okay, so keeping that in mind, so my first equation here, I'm going to multiply this guy by 4. Remember, what you do to one side, have to do to the other side. Okay, 4 times 7 gives us a 28x. 4 times 6 is our 24y. That's going to equal 4 times 1. And remember, this is just, that's equation 1 that we've multiplied by 4. Okay, so nothing crazy's happened. We've just multiplied equation 1 by 4. Equation 2, we said we're going to multiply by negative 6. Okay, negative 6. So now we get negative 6 times 4, so negative 24x. Negative 6 times the negative 4, like we just said. And hopefully you can visualize this. 24y minus 24y. When we add those two together, they're going to cancel out. Sum up to 0. Okay. So again, this is our same second equation, just multiply by negative 6. Okay, now I can add these two. 28x plus a negative 24x gives us 4x. 24y plus 24y gives us 0y. That's the whole reason why we did this. Y is gone. 4 plus a negative 24. Can we rewrite that as 4x? And x equals -5. Okay. Now we can take any of our equations here and substitute it in to find y. I guess we could, I don't know, doesn't matter. I'm going to use this guy. So now I have 4 times, instead of x, I'm going to put in -5, plus 4y equals 4. So I just took my x, substituted in there. negative 20 plus 4y equals 4. 4y is going to equal 24. So y is going to equal 6. And now I can just write that as an ordered pair, negative 5. And there you go. And that's how we solve a system of equations using elimination. This is the key concept to have down here, is this part right here. We're trying to get our coefficients to be the same, just opposites of each other. So we can multiply any equation by any number minus 0. So you can even divide, it's like multiplying by a fraction, anything like that. Okay? Okay. So this is probably the most complex we'll get to with systems of 2 variables with elimination, but hopefully this helped you.